A rabbit population starts with 4 rabbits and increases at a rate of n prime of t rabbits per week. What does 4 plus integral 0 to 26 of n prime of t dt represent? Okay, so first we know that the integral of a rate of change is the total change. That's one of our fundamental theorems of calculus. So is the change in what? Well, it's the change in whatever n is measuring, which is the rabbit population. So this is the change in rabbit population. And then we've got to make sure we get those limits of integration here in part of our sentence between t equals 0 and t equals 26. And then I'll put parenthetically measured in. And if you're not sure how to find the units, or if you're not sure what an integral represents, finding the units is oftentimes a good first step. So the units for the answer are just going to be the units for n prime times the units for t. So the units for n prime are rabbits per week. Rabbits per week. And then the units for t, for time here, presumably are weeks. So if we multiply rabbits per week by weeks, we get rabbits, which seems like a perfectly good unit for the rate of change in rabbit population. So we just discovered that this change in population is measured in rabbits. So what's that 4 plus doing? Well, we know the initial population was 4 rabbits. And so if we take the initial 4 rabbits we had, and then we add the change in population, then that should give us the actual population at the end of week 26. So then we'll write our final answer here in green, is that this thing represents the actual population. At t equals 26 weeks. Part B, if n prime of t is equal to e to the t over 10, how many rabbits will there be after a year? Okay, so same idea as before. The answer to this problem is easy to write down and then hard to figure out. So we'll write down just what we had up above, but instead of going to 26 weeks, we'll go from 0 to 52 weeks. N prime of t is now replaced with this particular function, e to the t over 10 dt. So if we can somehow figure out what that thing is equal to, then we win. We have our answer. So we'll use the technology version first, and then we'll do it out by hand. So depending on when you are watching this video in terms of where you are in the course, you may or may not have the tools yet to find that integral without the calculator. So if we don't, then we can do Math 9 and just type that integral in. E to the x, comma x, that's the variable. Whoops, should have been x over 10. Okay, so e to the x over 10, comma x, comma 0, comma 52. So if we've done this right, then that should be the value of the integral. But then remember there's a 4 plus sitting in the front of that. So we add 4 to that, and we get our rabbit population is just under 1807. So we'll say with technology, you can get the answer is about 1807. But if you have already seen U substitutions in your class, then you need to be able to do this one by hand in addition to being able to use the technology. So let's try that now. So what we need to do here, in order to find this integral, well, I'll copy the 4 plus, but we need to do a U substitution here. So off on the side, I'll do my U substitution. We're going to let U equal the exponent. Remember, if you have e to some stuff, then oftentimes letting u equal that stuff, that exponent, is a good idea. So that means that du is 1/10, and then we'll stick on the dt. And then all right, so then we'll start with our u substitution here. So this becomes integral. Instead of e to the t over 10, it becomes e to the u. That's getting the u in there in the simplest way possible. Then we're going to underline what we haven't substituted yet in the original integral. That's a dt. We need to find dt in this new equation and solve for it. So this tells me that dt is really 10 du. And so we're going to put that, I'll put it in red here, 10 du is exactly the same as dt. So it's okay to substitute there. Notice that I left the limits off. If you put 0 and 52, You are wrong, because the 0 and 52 are values of t, but we have decided to make our lives easier to change that t into some corresponding u. So really, if we're going to do this right, and why wouldn't we? We should go ahead and say, okay, if t is equal to 0, then how much is u? And if t is equal to 52, then how much is u? So we're going to go back to that equation right there and just substitute. When we plug 52 in for the t, we get 52 over 10, or 5.2. And if we plug 0 for the t, we get 0 over 10, which is just 0. And so I'll highlight these guys here in green and say those are the numbers that we need to put top and bottom. Keep them in the same order they were in before. So it used to be 0 on the bottom, still 0 on the bottom, and then up at the top is now a 5.2. And the nice thing is, once we do the actual antiderivative, we don't have to go back to the t's anymore. We'll just substitute those numbers, the 0 and the 5.2. Okay, so almost there. 4 plus. I'll copy the 10, kind of imagining pulling it to the front of the integral, outside the integral. The integral of e to the u du is simply e to the u, and then we're substituting 0 and 52. Both of them are u values. So I have like no space to work with here. Where can we go? Let's try squeezing in here. 4 plus 10 times, let's see, so we're going to do e to the 52. That's not a 52, that's a 5.2. 5.2, and then minus 10 times e to the 0. And that's what we need to calculate. So 4 plus 10 e to the 5.2, we're going to type in a second. E to the 0, it's really tempting to maybe just say anytime you plug 0 in for your variable, you get 0, but actually e to the 0 is not 0. E to the 0 is 1. So this is going to be a minus 10 here at the end. So last thing we can do before the calculator, I'll copy the 10 e to the 5.2, combine the 4 and negative 10, and this is the exact answer. 10 e to the 5.2 minus 6. We should be able to verify that it gives us the same. We hope it gives us the same thing we got before. So we're doing 10 e to the 5.2. And then we subtract off that 6. Fingers crossed, we should get exactly the 1806 and change that we saw above. Oh, isn't that lovely? So there's our answer. Certainly far easier if you're allowed to use the calculator's ability to do some calculus, but we can do it by hand even without the integral command on the calculator.